This problem, and similar to the way that we started the others, hopefully we can take the same concepts and extrapolate them. I begin by saying the general equation is E is K Q, I am recording, over R squared. Right? That's a general idea. And do we see that what we're telling ourselves is that the result of all of this, like the result of some charge, is going to give me some vector E, right? A resultant vector. Do we also see that that E is formed of the two components, EX and EY? Is everybody okay with that? Does that make sense? To say that the resultant of these charges, the effect of these charges is going to be an electric field that's going to have, it's going to be at some angle, and that angle is going to have some components in the X and the Y direction. Is everybody okay with this? Remember, if I say something that you don't understand, please make sure you ask. All right, okay. From this statement, then I can begin to say, okay, well, what causes this electric field? And in this case, it's going to be this delta Q. And then like we've done before, this delta Q, this little piece of charge, is a function of the charge density, which case is Q over L, the length of this, and that's going to be times, oh, sorry. What? No, lambda is it. Yeah. Oh, I'm just kind of working this out. This would be like some sort of, well, let me see. Not say. Do you see that this is a part of an arc length? Okay. It's over this little piece of length. And now we're going to take this through a logical progression. Do you see that Q, well, obviously it's Q, but this L is like 2 pi r divided by 4? Exactly. Do you see it's 2 pi r divided by 4? Or pi over 2r. Does that make sense? Right? Because 2 pi r would be the whole thing, divided by 4 is this section. So we get pi over 2 times r. And do you see that this delta L, that little length, is a section of that arc? This arc that's described by pi over 2r is, I mean, in most cases they call it arc length, call it S, right? So instead of this L, we're actually using S. And then this thing becomes that delta S, the little section of the arc length. And if you allow me to go one step more, does it make sense to you to say that this little section of the arc length can be described, the delta S, so what we've said is L is basically like S, which is equal to 2 pi r over 4, which gives us pi over 2r. And then we're saying that delta L, the little section of the length, is actually delta S, which is the arc length. And does it make sense to you that that is r delta theta? That it's the radius times the little section of length that sweeps over it. Okay, because remember, this thing is infinitely thin. We don't have to worry about the thickness of that. There's no delta r in this case. It's only sweeping through the arc length. So then, that gives us, ultimately, our final statement here. Oscar Wilson. So that gives us our ultimate statement of 2q over pi, and then there's an r here with r delta theta here. So those r's are going to cancel, and my delta q ultimately becomes 2q over pi delta theta. I know, the whole thing comes out like a house of cards. Everybody's still okay with this, right? And is everybody okay with the fact that if we say that that's theta, then we're saying that E is equal to E cos theta plus E sine theta. Everybody okay with that? Yeah. All right, so now our statement here, okay, let me see. What should be the correct? First, I'm saying we're taking the sum of these or something. I want to do it mathematically correct. Do I say something like that? The sum of all these? No, that's not right. Sorry, will be the sum of all of the little ones that come from the delta q's, right? Is that the math way to do it?
You could say sum of e to it, because technically it's a vector, so you're just adding up multiples.
Okay, so this is okay to say this?
Ask Alan.
That's because I don't want everybody to see my bad math. Okay, I haven't made very good math steps from here to here, but do you see what we're doing now? I'm just saying what we're doing logically is we're using the integral to add up all these little fields that are created, or we're finding the sum of all these little fields that are created by all these little tiny parcels of charge, all these little delta q's. Okay, so if you notice the same pattern that we've done, the same idea. We have this general statement that describes, for any given portion of this arc, this general statement describes the effect of that piece. And then we're now saying, okay, we got to add up all of those little pieces, and so then we take the integral of something like this.
Yeah, but it's the second term, so it's in cosine.
Okay, let's go ahead. And I'll go of the electric fields is going to be 2kq over pi r squared. And we're taking this integral of pi over 2 cosine theta d theta. And that's that I hat vector plus 0 to pi over 2 sine theta d theta. And that's that j hat vector. Okay, so yeah, so now we say this is equal to a, because I don't want to rewrite that, it's annoying. And the integral of this was sine theta, so we have sine theta from 0 to pi over 2 plus, and then here we're saying kind of like negative cosine theta from 0 to pi over 2. I don't know, just so people can see it. I mean, we can take that negative and bring it out there, right? Is everybody cool with that? So then, sine of pi over 2, as we said, is 1 minus 0 is 1, right?
No, 0.
Sorry, what did I just say?
Oh, I thought you said minus.
Oh, okay,
yeah,
cool.
You're right.
Okay, don't forget, we got these things here. So this is a times 1 times I hat plus, and then here, this gives us the cosine of pi over 2 is 0 minus cosine of 0, which gives us negative 1. Negative 1, but then I have a negative in front of it, which gives us positive 1. And that's what we get. And remember what Keith said in the very beginning. He said, shouldn't the components on the outsides kind of cancel each other out? Right, so that if you looked at this, say like vertically, right, this one's going to produce something that way. This one's going to produce something that way. Yeah, like if I turn this so that instead of having it be in the third quadrant, if I dropped it so that the thing pointed straight up,
yeah.
Then we could see that these horizontal components would all cancel. And then you're going to be left with some result straight up that way. And that result in the
What's he looking at?
yeah, it's going to be on YouTube.